Okay, welcome everybody. We're live on YouTube now. Let me go ahead and post that link out to various audiences, and then I'll be back and we'll get going. Actually, Vincent, if you want to go, while I'm posting the link, if you want to go ahead and just, I'm going to unshare for a second. Go ahead and share your screen. I will stop my share, and you should be able to. Cool.
Does it
It looks
work?
great. I see it perfectly. And just test your video, or test your audio, excuse me. We can see your video is good.
Okay.
All right.
So, hello. I'm
Hello.
now.
Yeah, loud and clear.
Loud and clear. Wonderful. Okay, great. If you want to stop share, Kanti, you want to go ahead and test your share?
Yes, 1 second. Sorry, can you see my screen?
I can perfectly.
Okay,
Looks
yes.
perfect.
Looks great.
Yeah.
Guy with dark clouds behind him. It's kind of spooky. Good. All right. Give me a second here. I'm going to go ahead and I'm going to go on mute again while I post a couple links just to remind people that we're live, and we can get going. Hello, folks. Welcome to the July ClickHouse SF Bay Area Meetup. I'm Robert Hodges. I'm just doing a little bit of housekeeping to get links posted into Slack and Telegram, and then we'll get started. Our presenters are all here. We're just waiting for you, the attendees, to come in, and I already see a few people joining. So I'll be right back. Okay, looks like we've got a few viewers out on YouTube. Opening up, I'm going to give people a couple more minutes to come in before we start the meeting. But what I'm going to do in the meantime, I see folks coming in. I'm going to go ahead and just allow everybody to talk. We're using, for those of you on Zoom, if you want to say hi and where you're from, feel free to jump in and introduce yourself. Don't be shy.
Hi, this is Pauline. I don't know if you guys can hear me.
We can hear you perfectly.
Oh, thank you. I'm with Cisco Systems.
Welcome, Pauline. It's great to see you again. It's been a while since we had the Cisco meetups, the meetups at the Cisco offices in San Francisco. Those were really nice.
Yeah, thanks.
Other folks on the call who'd like to introduce themselves, just please don't be shy. We're all pretty friendly here.
Hi, this is Sasha Volodnitsky. I'm with Nephologic.
Welcome, Sasha.
I haven't talked to you for a while.
I know you, but you've attended many of the meetups, a number of the
Yeah.
meetups as well. Great to see you again. Other
There's
folks?
an interesting topic today, so.
The networking, I would guess.
Right, exactly.
Yep. I thought you'd be interested. Okay. So yeah, it's funny. We get some really good networking talks here. So I'm going to give folks a couple more minutes. Here's what I'm going to do. Oh, hey, Gilad, welcome. I'm allowing everybody to talk. So please feel free to come on in and introduce yourselves. Gilad, if you want to say hi.
Hey, what's up?
Hey, glad to meet you in person.
Yes, almost.
Well, kind of. Yeah, let's here. I'll show you my video so y'all can see what I look like. We have a number of very handsome or good-looking presenters today, as well as attendees, of course. So I'm actually coming to you from not from San Francisco today, but from Seattle. I'm up visiting my mom, so we're coming from the north. But the great thing about Zoom is, who cares? So let's jump in. You can see see how we're posted on Telegram. We'll have more people joining. I've posted the YouTube links as well as Zoom, and I think we should get started. We have a couple of great talks today. Before we dive in, actually, let me do the following. Let me start our screen recording on Zoom just a second here. I always forget to do this. Okay, Zoom is recording it. We've also got a live streaming to YouTube. We'll pick whichever one's better and post it afterwards, and post the links out to you so that in case you want to see it again. Before we dive in, I'd just like to give a little bit of an introduction and some news. So this is, as we can see here on this invite, this is the July 2022 virtual meetup for ClickHouse. We're the SF Bay Area ClickHouse meetup, but in fact, since COVID, we've actually been one of the worldwide ClickHouse meetups. We do it in the middle of the afternoon or early afternoon Pacific time, so that basically people from Europe, sort of from a wide range of other time zones, can also attend. So welcome everybody. This meetup happens, if this is your first time attending, we typically do it about every 2 months. Here's a question, Jocelyn. Here, we're pretty informal. Jocelyn, where is the chat screen I just saw? Is there a group in Slack or Discord? There actually isn't we're using the chat for Zoom. If you're listening on, by the way, if you are listening on YouTube, you can go ahead and enter comments on the YouTube chat, and we will forward them. So, okay, so hope that answered that. Other things, so this meeting's being recorded. We'll publish it later. We'll publish slides. We have 2 great talks. Speaking of meetups, we'll have another ClickHouse Bay Area meetup in a couple months. I think what we're going to do is something special. We're actually going to try and do one in person if I can get if we can find a place to hold it. That will be great. And so we will we'll let you know about that. It will be sometime in September. There's also, for those of you who use Kubernetes and use data, there is going to be a data on Kubernetes meetup on the 18th of August. I invite you to come to that. That's an in-person one at Intuit. We also had a recent data on Kubernetes meetup in San Francisco, which was kind of cool. First chance for sort of the Kubernetes data community meet. We talked about ClickHouse, but also a bunch of other databases as well. I think I've babbled enough, so I'm going to stop. And what I'd like to do is go ahead and looks like I canceled the video. Let's see, just one second. I'm going to enable, actually what I'm going to do is not enable the videos for now, because during the talks it then it can sometimes screw up the presentations. But what we're going to do is jump into the first talk, and that is Agvorado, a flow collector and visualizer backed by ClickHouse, and it's by Vincent Bernat of Free Mobile. And I'm not going to say anything more because you can read it for yourself in the invite, and Vincent is going to tell you all about it. So Vincent, I'm going to stop my share, and please go ahead.
Hello, so I am Vincent Bernat. I'm a French network engineer working at Free. I'm doing this presentation from Paris, France. So it's nice to see you. I'm going to present Agvorado, which is a network flow collector and visualizer backed by ClickHouse. So Agvorado was developed internally at Free. Free is a French ISP founded in 1999. It was one of the first to offer internet access without a subscription or a surcharge phone number in France. It contributed to the DSL expansion in France by driving prices down. It was quite innovative by introducing the Freebox, which is the first triple play setup box, including internet, TV, and phone services. Free also contributed a lot to IPv6 adoption in France or around the world in 2008. The mobile offer is also quite innovative with a big data allowance. You have more than 100 gig of data included, and you can roam around the world with that. But we are not available in San Francisco or outside France yet. So Agvorado is a NetFlow IPFix S-Flow collector. Internet routers send a sample of the packets they receive to Agvorado, like one packet out of 10,000. There are several protocols for that. IPFix is the IETF version of NetFlow. NetFlow is a Cisco proprietary protocol. And S-Flow is another kind of protocol. The difference is that it does not aggregate data. It sends data in real time. But it's a small difference because NetFlow is also able to send data almost in real time with a good configuration. You can have a 10-second lag. So mostly, you choose the protocol that your routers support. So it's important to support several protocols because not all routers support all protocols. So Agvorado receives that, and then it enriches the flow with additional data. Notably, it adds geo-IP information using the MaxMind database. It adds interface names and description with the SNMP protocol, and it adds AS numbers. So AS numbers is the main way to identify organization on the internet. From the IP address, you can get the AS number, and from the AS number, you can get the name. We also add some attributes to routers using classification rules. We add the location, the role, the tenant of the router, and we also add attributes to interface, the provider, the boundary, the connectivity. Is it a transit interface, a peering interface? All this information are very useful to have when you need to query the data that you have collected. And then Agvorado will serialize the flow using protobuf and send that to a Kafka cluster. Since recently, it is an open source project. We have published it on GitHub. And there is also a nice web front end to query the data. I have a few screenshots, but I will do a live demo. Okay, no. So you can try the demo yourself at the URL demo.agvorado.net. It's running on a small virtual machine. It uses fake data. So the home page is just a few metrics to show that it works correctly, but it also displays the last received flows. So you can see what it looks like. You have a timestamp, the number of bytes, the number of packets, the router that sends the flow, its name. The following attributes comes from the classification rules. The sampling rate, which is quite high for the demo. It means that the router sent one flow out of 50,000 flow it received. The source address, the source AS number. GeoIP is not configured, so you don't get the country. You get the source port. For the incoming interface, you get the name, the description, the speed, and also from the classification rules, the fact that it's an external facing interface, it's connected to the internet. It's a transit interface connected to Cogent, which is a transit provider. And you have the same stuff for the destination address, country, and the outgoing interface. You have E-type, which is mostly IPv4 or IPv6. Forwarding status, 64 means it has been forwarded. 128 means the packet has been dropped. So if you have firewall rules, it's interesting. And the protocol, it's 17 for UDP, 6 for TCP. So most of the fields are received from the flow, but some of them we added it later. Okay, but the most interesting tab is the visualize tables. Let me zoom back a bit to show the last 7 days. So it answers the question, where does my traffic come from? So we can see, for example, in this demo, most of the traffic comes from Netflix, but also Google and Facebook. You can, there is a filter that you can add more stuff. Like, for example, I want to only see the IPv6 traffic. So I can input this filter and I apply and I get the IPv6 traffic. So because all the data is fake, it's a bit difficult to see the difference, but you see IPv6 is at most 100 gigabit of traffic, while the whole traffic was more 90 gigabit of traffic. Another interesting visualization that the web interface shows is a Sankey graph. It's another kind of visualization, and it shows you the top 3 talkers, Netflix, Google, and Facebook. But it can answer, it shows, for example, that 2/3 of the traffic is going to transit providers, 1/3 is going to Internet Exchange. And Internet Exchange is a place where people can connect to the same switch and exchange traffic for free or for free or not. But you don't get the whole internet just by going to Internet Exchange. If you want to get the whole internet, you need to have a transit provider. And so, for example, we can answer the question, how do we get Google traffic? It seems that we get most of the traffic using a transit provider, but a small part is going to an Internet Exchange. It's also very useful visualization to get for a network engineer. So let me get back to the presentation. So how did we use ClickHouse? So that's the table that we have in our ClickHouse setup. First, a bit of warning. It's the first time I have used ClickHouse for this project. I am a network engineer, not a database engineer. So I have a few mentions of database, but very, very light. So feedback is welcome, and take everything with a grain of salt. So the purple square are the tables, the blue ones are the views, and the white one are the dictionaries. So I was too fast. Instead, I think I forgot to tell. Okay, sorry. So, like I told previously, flows are coming from Kafka on the flow-through table, which is not backed by a disk storage. So there is a consumer extracting the flows and sending them to the flows table, which is a mine table containing all the flows. Then we have a few other flows table, which are aggregating data over time to take less space and speed up queries. I will go in more details in the next slides. So ingestion is done using the Kafka engine. We receive the data using the Kafka engine. The data is decoded with the protobuf format. Protobuf schemas are version. They are coming for version topics from Kafka and stored in versions tables. The raw consumers, the flows table itself is not versions. The raw consumers will normalize data to match the data format in the flows table. When there is a schema change, we increase the version number. It allows seamless updates. If you have old collectors running in your network, it still works. For example, they will continue to send the flows to the flows v1 topic. It will be using the flow message v1 schema, and it will be handled by the flows one row Kafka engine and the flows one row consumer to normalize the data. The downside of this, there is no registry for the schemas. So you have to copy during on each upgrade, you have to copy the schema on each ClickHouse server, then restart the server. It's a bit annoying, but you don't lose any data because Kafka will buffer the message while ClickHouse is restarting. ClickHouse is able to use a registry when you are using Agvorado, but I think that it doesn't work with protobuf. So the main table is the flows table. There is a partial view of it. Many columns are omitted. For each source column, you should have a DST column. For each in EF column, you have an out interface column matching that. There's nothing special. We use low cardinality when it makes sense. And the table is ordered by time received because every queries will use this column. So the flows table in our setup keeps 15 days of data. It's half of terabyte of data. It's very slow to query for more than 1 hour of data and almost impossible to query 1 day, 2 days, 3 days. It's possible, but it takes many seconds, and we don't want that. We want an instant response. Also, we want to keep data for 5 years. This is a common requirement for this kind of setup, to be able to look at what happened last year at the same period. So to be able to do that, we need to aggregate data when it gets older. ClickHouse can aggregate data, but it was not flexible enough for us. So we use an approach inspired by the round-robin database. Round-robin database are the ancestor of the time series database. The data is stored in files in a circular buffer, and after some time, the data is consolidated using a specific function, mostly max, min, and average. So we do that. We use a summing merge tree on bytes and packets, but we also drop IP addresses and TCP and UDP ports. We cannot keep IP addresses for too long for legal reasons. because it's personally identifiable data. And it's not that interesting past a few days to know all the IP address. The interesting parts of the IP address survive through the network classification. We can attach a region to an IP address, for example, or through the information given by the IS numbers. We know this IP address is owned by Facebook, for example. So past a few days, we don't need the IP address anymore. For the TCP and UDP ports, it's for another reason. We could have kept them, but they are very random. Most of the time, the source port or the destination ports are known. For example, port 18 or 553 for HTTP, but the other ports can be totally random. So it's a lot of random data. It's not easy to know which port is a server port, so it's easier to drop it. And again, past a few days, it's not very interesting to still keep the ports. And it helps compress the data far more. It helps aggregate the data more efficiently to not have that. Unlike our database, we don't keep the max min values. That's something that we should do at some point, because when you zoom out, I can show you on the demo, maybe it will be interesting. When you zoom out, you see, it seems that I have the max at 60 gigabit of traffic. But if I ask for the last 30 days instead, you see the max is a bit less. It's because it's not really a max, it's an average over the resolution of the table. So an average over 5 minutes and an average over 1 hour will give a different maximum value. But that's something that could be fixable with ClickHouse, I think. So we have a 1 minute aggregate table, a 5 minute aggregate table, and a 1 hour aggregate table that keep data for 7 days, 90 days, or for 5 years very efficiently. And Agvorado automatically choose the best table to query depending on the time range, the columns requested. If you request an IP address, source address, or destination address, you will have to use the main table and the resolution of the output. I wanted to show you how we feed data to the aggregated table. Because it shows a nice feature of ClickHouse. You can select everything with the star except a few columns. So we want to exclude source address, destination address, source port, destination port. It's very easy to do that. And we can also replace some columns. For example, the time received, we round it to the previous hour. So it's very nice to not to be able to do that. The exporters table is just a small helper table to have a list of exporter name, address, and interface name and description and other data. It's mostly used for completing user input when the user is writing the query filter. I wanted to show you that because it's another nice feature of ClickHouse. With the OS, you have a lot of ways to manipulate array. So with a single query, I can populate the table using array join and array enumerate. So another interesting part are the dictionaries. We use 3 dictionaries. One dictionary to map IS number to names. There are about 100,000 IS numbers. So you say one IS number, you can get the name. And we have another dictionary for protocol numbers to names. So protocol number 17 is a user datagram protocol. Those 2 protocol numbers are immutables. IS name change very infrequently, are mostly cosmetic. For example, you can have a Twitch TV. The IS name for Twitch TV can change later to Amazon Twitch, for example, but it's mostly cosmetic and it's only used for display purpose. So we use those dictionaries during queries. But the third dictionary map networks like this to a name, a role, a region, and a tenant. And this time we use this dictionary during ingestion to materialize some columns because we don't want historic data to change when you reallocate a subnet to another region. So the network classification is done during ingestion using a materials view where we select everything from what we receive from Kafka, and we just add the source net name, source net role, etc., using the dictionary. The network dictionary is using the IP tree layout. It means that given an IP address, like source address or destination address, ClickHouse is able to do a very fast IP lookup to select the right network. This is not the only data generated from other data. If you remember, we have also data generated from geolocation, from AS number, and from classification. It's not done in ClickHouse. For the geo IP data, it could have been done in ClickHouse using the same system. It would have worked, but it was easy to do that in Agvorado directly. But the classification is done with user-provided rules. So this time, it's easier to do that in the backend and not in ClickHouse. So if you remember the demo, user input a time range columns in the web interface, they are called dimensions, and a filter expression. And the filter expression is also something that I find interesting. Our users are network engineers. They have some, they may know SQL, but they are not fluent in SQL, but they know it well enough that we are using the filter and are a SQL-like language that we translate to the ClickHouse SQL using a parser. Our domain is simpler, so we can take shortcuts or we can simplify some aspects. For example, IP address does not need to be quoted. You can use double quote or single quotes. It doesn't make a difference. You can use some fixed value. A type is should be an integer, but we can give a name in this case. Everything to be easier to use. And the parser will translate that to ClickHouse SQL. It's also safe because we parse the filter and then we build the ClickHouse SQL query. If you use an unknown column or you make a syntax error or something like that, the parser will fail with an error message and no query is built. So you cannot inject anything in ClickHouse, even if ClickHouse is not very vulnerable to injection attacks. It's not possible because the parser needs to understand what you want and it translates that to ClickHouse. Then the whole user query is translated to ClickHouse, and ClickHouse helps a lot to return data that will be directly exploitable by the front end. For example, when some value are missing, we can fill it automatically with 0 value. That's what is done here. You notice that I am using the aggregated table using the 5-minute aggregation. There is another magic value here, which is 600. We adapt the resolution requested by the user, which may be 632 seconds, one value every 632 seconds. We adapt it to match the resolution of the table. It should be a multiple of the resolution of the table for the data to look good. So since the resolution is 300 seconds, the user requested almost 1 point every 600 seconds. So we will give it 1 point every 600 seconds. There is a subquery here selecting the user requested to get the source AS numbers. And we will select the top 10 AS numbers matching the query during the same, it's redacted here, the same time filter on the same user filter. We will select the top AS numbers. And when for each AS that we get, each AS number that we get, if it's one of the top 10, we will display the AS number along with its name using the dictionary. Otherwise, we will just display other. This way, we don't have an infinite list of highest numbers returned to the user. The backend, let's switch to the backend. It's written in Go, in the Go language, and we are using the ClickHouse Go /v2 bindings, which is using the native client-server protocol. It's a very low-level interface, but it's fine for us because abstractions often come with restrictions. The documentation is pretty poor. It's not up to date with Go standards, but there are a few examples to understand how it works, and otherwise, it works very well. We write a lot of unit tests, but they are not run against a real database. For each query, we provide canned results by using a mock generated with Go mock. So, for example, if during the test there is this query is issued, Go mock will generate a false function that will answer the this result: customer 1, customer 2, customer 3. It enables us to do a lot of tests very fast without relying on an external database. The last thing that I wanted to mention are the migrations. With a regular database, it's a product often issue migrations when you update. And for ClickHouse, it may be a bit more complex because you cannot do whatever you want. So we have an orchestrator which manages the different internal and external components, including ClickHouse and Kafka. But he manages the schema migration, and it's done with Go code. Each migration step has a description, a test, and a function. There is no state. Each migration step is executed on start, and the test says if a step can be skipped or not. And it's only managing forward migration. So the current step, for example, are create the dictionaries, protocol, ASN, and network dictionary, creating the flows table, the main one and the aggregated one. If you upgrade from an old schema, there is a step to add the missing columns. There is a step to create the consumer flows table. There is a step to configure the TTL associated with each table. This means that if the user configure a different TTL and restart the orchestrator, the TTL will be updated. And then a step for the exporter view, the offload table, etc., etc. And mostly there are two kinds of steps. The ones that will modify the dictionaries and a view, we don't need to keep data for this one. So we check. We do two checks. We check if the table exists, the view, or the dictionary exists, and we check if the table has the right columns at the right position. So it's done with by hashing the name type position from the system columns table and checking against hard-coded value. So it's quite nice that ClickHouse exposes a lot of things in the system database because it enables us to do query like that. And the second kind of steps that we can have is where we want to keep existing data. So in this case, we use mutation. We test, do we have the table and the columns that we want to add? If not, then we use alter table to add the column. There are many limits of what you can mutate, but with some compromise until today, we were able to do what we wanted to do. Migrations are tested using, they are part of the automated test. There is a ClickHouse database spawned in the container, and the migration are tested from various states, including from an empty database. Each test must get the same final state, and each time a new migration step is added, the final state is recorded to be used in future steps using the query on the slide. This enables us to ensure that we are able to, that a user is able to migrate from one version to any other version. Our setup is quite small. We are running everything on a single VM, including Kafka and Agvorado itself. Everything is running in container using Docker Compose. So it's a very simple setup. 1 terabyte of disk, 64 gig of RAM. Currently, it's 30,000 flow per second. The target for is 100. You see some usage graph for CPU, memory, and disk. Everything is quite low, but there is a DDoS system running in the background every 5 seconds doing requests, and it's the one generating most of the load, in fact. So to conclude, my opinions about ClickHouse, it's a great out-of-the-box experience, great documentation. There are many built-in functions available, string function that convert to human readable stuff. It really feels like that this is something where usability problems are solved directly in ClickHouse instead of having another layer for that. It feels a bit like magic because, for example, unlike another popular way to do the same thing was to use Elasticsearch. Unlike Elasticsearch, ClickHouse is very fast without much effort and stays very fast. Managing an Elasticsearch cluster is far more difficult for this kind of usage. Aggregating merge trees take some time to understand how they work, and it's easy to do something that looks right, but that isn't. For example, if you aggregate using average, you don't get what you expect. But of course, ClickHouse has functions to help doing that. So that's all for me. I welcome a few questions if you want.
Vincent, that was an absolutely awesome talk. And we do have a couple questions queued up. I can see them in, we have a couple from Gilad. Can you see the Q&A box?
Yes.
Yeah, so there's the first one is, you can see it, does Agvorado parse only layer 3 protocols? How does it detect which application it is?
It's a limitation of using the network protocols that are used to the NetFlow, IPFix, SFlow collector protocols are a layer. They collect layer 2 information. NetFlow, IPFix are limited to layer 2 information plus some metadata like the AS numbers. SFlow is able to pick more inside the packets. SFlow, you can configure SFlow to tell, give me the layer 3 headers, layer 4 headers, but you can give me 200 bytes of each sample packet as well, and you can do that. But currently, Agvorado is not using that. So you don't know, you can guess the application using ports. Using IP address, it depends. If, for example, you have a Kubernetes cluster, the IP address should be able to give you the application, the target application. You can use that. But yes, currently, if you don't know for sure that it's HTTP, you don't know which HTTP request was done, it's not this kind of tool yet.
Cool. The next question from Gilad has my name on it, but I can't really answer it. And Gilad said, would you suggest having a single table instead of all 3 tables? But Gilad, can you, if you want to just speak up, I think you should be able to talk. You can describe what you had in mind there.
So, yes. Right now I see that you have 3 tables, one for 1 minute aggregation, 5 minute aggregation, 1 hour aggregation. Have you tested using one table that does DTL and aggregates 1 minute rows to be 5 minutes rows and 5 minutes rows to be 1 hour rows, and all in the same table, having let's say a different one column to identify the bucket size of the row? Yes,
I have tried that, but there is, when you aggregate data inside the same table, there is a requirement that the primary key, I may be wrong, but I didn't succeed to do that because there is a requirement that the primary key does not change. And in the primary key, we have the time received, and I want to round that to the nearest minute, nearest 5 minutes, and nearest hour. So I can do one. I can, for example, I can have one column with time received. Then I need another column with time received rounded at the minute, time received rounded at 5 minutes, and time received rounded at 1 hour. I need to have
Yes,
the
you are.
3 columns to exist to be able to do the aggregation into the same table. And it seems more complex, but maybe it will be a better approach. I would be interested to get feedback on that. Maybe it would have worked, but because the primary key cannot be modified, it means that if I want to add a new kind of aggregation, for example, I want to aggregate at 10 minutes, I cannot mutate the table to do that because the primary key cannot change. So
Yes,
that's the main reasons that I did go for 3 tables, even if it makes the application a bit more complex because you have to select a table.
Nice. So I just want to say that we have a solution close to this, and we did one table, but we haven't tested the performance about many tables with one table. So it was interesting to ask.
Gilad, you had another question, which was to Vincent, which is how did you deploy ClickHouse? Did you use Kubernetes? And Vincent, it looked like you were you using Docker Compose? Did I see that correctly?
Yes, but because currently it's still a bit a POC, but it's working so well that we didn't try to do better. I wasn't expected to be able to have all our data on a single VM, but so currently it's a bit of proof of concept, but it's gone to production this way. So it's a single VM using Docker Compose. So you do Docker Compose app and you get your working setup, and with not a lot of memory. So everything is running into containers, including ClickHouse. So there is no cluster. It's a single node ClickHouse deployment currently.
Cool. Yeah, that's a
Wow.
great. Yeah, that's a really great example. I have a question. I don't see any questions on YouTube. If you folks want to ask something, feel free to throw it into the chat. Vincent, I had one. The UI that you have looks really great. How did you build that?
Oh, so it was a bit of pain because I am not a front-end developer. So it's a Vue.js. So it's a Vue.js. This one, this framework with Tailwind CSS. This framework. That's mostly all. If you want to look, I think it's explained a bit more in the documentation. Since it's open source, you can have a bit of look at it.
Yeah.
But and for the graph, sorry, an important component of the graph. It's HCharts. It's an Apache project which is called HCharts. That's the one handling the graph, and it's a really great project. If you need to do some front-end work to get graph, it's very robust and very versatile. And it took me some time to discover it.
Yeah, it looks awesome, and I like the interactivity of it is outstanding. It's really cool. Good. Are there any other questions to Vincent before we proceed to the next talk?
Yes, I have another one. Do you have a plan to parse HTTP?
A plan to what? Sorry.
Parse HTTP. So to investigate HTTP protocol as well, layer 7.
It's at 3, we are using the NetFlow protocol, and the NetFlow protocol doesn't allow to peek at the layer 7. We would have to use SFlow, and we are an internet service provider, so we don't need that. So there is no plan yet. There is no plan yet, and it's mostly a tool for network telco network engineer or data center engineer, but it could be interesting, but no plan.
Nice.
Great.
Okay, thank you.
All right, thanks for the great questions. And I think I don't see any further questions queued up right now unless I'm missing something. Vincent, thank you so much for a totally awesome talk. This was really enlightening. And yeah, I think we can stamp you as an honorary database engineer. You did everything great. So it's a real model. Next up, I would like to introduce my colleague, Kanti Subramanian. He is going to be talking about replication from MySQL to ClickHouse using Kafka. So this is going to turn out to be a bit of a Kafka fest in our two talks today. So Kanti, go ahead and take it away.
Sorry, can you guys hear me?
Perfectly.
All right.
And your screen is visible.
Okay, perfect. All right, I had some notes at the bottom. I can't see them, which is weird. Anyway, yeah, so we actually did this talk at Percona Live in May. We've done considerable work, I think, in the last couple of months. So the talk is about how you can replicate data from MySQL to ClickHouse using a Kafka sync connector. So I'm missing the introduction page. A quick introduction about myself. Before this, I've been a data engineer, so I've worked in different companies writing ETL pipelines. So very similar kind of work, moving data from transactional databases into data warehouses using tools like Airflow, Kafka, and others. I'm also an open source contributor. I've been with Altinity for a while now. My focus is I'm an open source contributor and a dev advocate. All right, so the question is, why are we doing this? I'm pretty sure a lot of people have the same use case. So a lot of the data, in this example, e-commerce transactions and web server logs, reside in your MySQL or some sort of transactional database. You want to be able to pull that on a regular basis into your data warehouse so you can perform analytics and then visualize the analytics on visualization tools so that people can take actions. So it's either the management tool who looks at sales numbers every day, or in this example, like you want to be able to say flag fraudulent transactions in real time. All right. So a brief list of some of the features we were targeting when we started the project is we wanted to support Avro. Like based on our testing, we found Avro has a smaller payload compared to JSON data, and so that significantly increases the throughput. Exactly one semantics. So we wanted to make sure that we don't introduce duplicates when data is transferred from MySQL to ClickHouse. We wanted to support updates and deletes going into ClickHouse. As you might know, it's not supported out of the box in ClickHouse. Support for multiple topics. So we have, and this is actually done in other connectors. If you have a requirement of mapping a source table into a different table in ClickHouse, you could specify a mapping configuration variable. I'll get into that in detail. One of the useful features I found as a data engineer is the ability to auto create tables. So you don't want to be, if you're ingesting a lot of tables from your source, it's convenient if your connector automatically infers the schema and creates the table in ClickHouse. And the last one is end-to-end monitoring. It just makes the life of a data engineer much easier, so you can visualize what's going on, and when your pipelines are down, you can take immediate action. This is the overall architecture. So MySQL is our source database. So Debezium is kind of the core component in this setup. So Debezium supports MySQL, Postgres, SQL Server, Oracle, and even Cassandra. So Debezium reads the binary logs from MySQL, and then transforms the messages from MySQL into a common unified schema, and writes it into Kafka. And because we use Avro, the schemas are actually registered in. We currently use Apicurio, but this is interchangeable with Confluence Schema Registry. So the schema is stored in the schema registry, but just a version is passed into the payload, which makes the payload smaller. And then we have the sync connector that we've been working on, which basically reads the messages from the Kafka queue, and then uses the ClickHouse JDBC driver and writes the data into ClickHouse. I just want to make sure if there are no questions so far, I guess, so I'll keep going. One of the most important reasons we used Kafka is the inbuilt support for parallelism. So this is a diagram that talks about how if a Kafka producer writes the records using a partition key, and so in this example, if we have 8 records, and then let's assume it uses some sort of partition key. I mean, for example, this could be a country. So partition 1 could be the US, partition 2 could be a different country. So the idea is the producer would, the data would automatically be distributed across the different partitions, and any consumer, and Sync Connector itself as a Kafka consumer, would be able to parallelly read all these partitions in different threads. So this significantly increases the throughput, and also it also has a high availability component to it. So if for some reason partition 1 dies, Kafka would automatically redistribute the messages from partition 1 into the other partitions. That's the part of the Kafka rebalancing mechanism. Keep going. So yeah, this is just the part I was talking about before, is how Debezium or any source connector for that matter transforms the source database data types into Kafka Connect / Debezium data types. So when we read the data from Kafka, we don't really know about the source. I mean, we do get some metadata about bin logs and transaction IDs and GT IDs, but most of the data type is abstracted. When we read it in the sync, we read it as Debezium / Kafka Connect data type. So this slide is just how the MySQL data types get mapped into ClickHouse. So for example, big int and date time is mapped into Debezium date, and in ClickHouse we map it to a date. So one interesting functionality here is the date ranges in MySQL and ClickHouse are different. So we actually have additional logic to limit the date in ClickHouse so that we don't get errors. Right, so we talked about, so inserts, it's fairly easy. Updates and deletes are not supported in ClickHouse. So we use, so our implementation uses replacing merge street engine in ClickHouse. So if you read through the documents, replacing merge tree would collapse rows based on the key that you define in the order by. So in this example, if your order by key is, say, the third column ID, and if you have duplicate records, and if the version number is higher, then ClickHouse would automatically drop the first row with the version 1 and then keep the second row with the higher version number. So we'll just see how it's, I'll get to this. So yeah, so this example, so the first, let's assume that the first row is an insert into the table. It's got 4 columns. And so on MySQL, let's assume that this is the row that's been inserted with values 1, 2, 2, and 44. We created a replacing merge tree with ID as, with the order by as ID. I think, yeah, order by as ID. And then after a while, we get an update for the same row with different values. So one thing to note is the sign and the version column are something that's added in the sync connector. So for updates, we actually use the transaction ID, which is part of the GTID from a MySQL database. The transaction ID is a number it's increasing, and it's used to map the transactions on the source database. We use that as a version column. So in this case, you will see that it's 1400 and 1401. And when ClickHouse does the merging in the background, it'll automatically drop the first row because it has a lower version number, and it'll keep the second row with 1401. So yeah, it just, in reality, it just looks like your insert was, I mean, you never add an insert, but you only see the row with the updated values. Very similar to what you see in MySQL. The way and deletes are handled, we actually tried collapsing merge tree and replacing merge tree. A lot of credit to Arno was on the call. We worked closely with the financial services client in trying out and testing the performance. So this came out from a lot of our tests. A replacing merge tree works better than a collapsing merge tree, just because we use the transaction number and it accounts for data that's distributed across different partitions. Coming back to delete, the way we handle delete is we set the sign column as -1, and the way we don't really, we're kind of waiting for the lightweight deletes in ClickHouse to be implemented, but for now, one way to ignore deletes is to set a row policy where you can hide records with this sign column equals -1. Right. Yes, so Gilad, I think I answered your question. All right, I'm gonna continue.
Let me just read that question for you, Kanti, because we've got people on YouTube who may not have heard it. So the question was, as far as I know, replacing merge tree cannot delete. Only collapsing merge tree has sign and version. Why use replacing merge tree with hiding row policy instead? And as you say, I think you answered that fully.
Okay, perfect. All right. I'm gonna skip to the demo. Or Robert, do you want to go through other questions? Sorry.
Yeah. Do you want to? Actually, you can take them now, or you can take them at the end. What's your preference?
I can take it now.
Okay, great. So here's another one asking, did you compare performance versus an approach with aggregating merge tree and argmax merge function equivalent to a dedupe by latest index? You know, it's funny. It's funny that Leandro mentioned this because we have discussed that exact thing a couple hours ago. Do you want to take that one, Kanti?
Yeah, we didn't really try that, but yeah, we did talk about it today. But that's a good point. Yeah, we'll try the other aggregating merge tree engine.
This would, yeah, and this would definitely work. I mean, if it doesn't work, this suggestion, and just so everybody understands, what we're talking about is basically using using aggregation combined with, for example, you know, we could tap into you know, like use a materialized view to make this work. But basically, we would just remember the last row, and in fact, we could even delete stuff. So and this would definitely work. If it didn't work, then ClickHouse itself is broken, but it's more complex than what we're describing here.
Okay. Sorry, is there more questions?
Nope, that's it. I don't see any on YouTube, so go for the demo.
All right. Okay, fingers crossed. Hopefully the demo works. So yeah, this is the GitHub project. It's open source. So feel free to download it and try it out. Let me see if I can close this. Oops. Sorry, I think I stopped sharing. I'm gonna share again. All right, so if you clone the project and then go to deploy Docker, we have a Docker Compose, and I just started Docker Compose. So Docker Compose starts all the different components that we talked about in the previous diagram. So it starts a MySQL instance, a Debezium source connector. We use Red Panda, so Red Panda, and a sync connector and ClickHouse. Yeah, and then we also have Grafana and Prometheus for monitoring. All right, so what I'm gonna do is, one thing to note is there's two different components of Debezium. There's a snapshot mode, which pulls in all the data that resides in your source database. So if you have 1 million rows, and if you want to pull that into Kafka, you can define the mode as snapshot, and then there's a streaming mode, which will constantly stream any changes to your source database as CDC events. So I'm gonna try to see if we can run so we already have some seed data inserted into MySQL. So as soon as we run the script, which creates, so Kafka Connect uses a REST API to create the connector process. So this is what it does. It does a curl with the payload, and that's where you define all the different components of Debezium. So it looks like it started, and then we're gonna run the schema register, the sync connector. All right, so okay, one thing actually to note is we have the auto create table setup configuration enabled. So that'll automatically create the table in ClickHouse. So in this example, Oh, that's, yeah. So it created the employees table, and okay, and then so here, this is one of the use cases I was talking about before. Is we want to be able to map employees predated MySQL table into employees. So we have this convenient configuration where you can define your source table / topic, and then your destination is table name, which in this case is employees. So looks like it did the initial snapshot. Just gonna do a quick count check. So yeah, we have 300,000 rows in ClickHouse, and then we have 300,000 rows in MySQL. Just 1 second. Just gonna walk through. Yeah. So these are some of the dashboards that Debezium offers, which is pretty useful. So we did a snapshot. So you can actually look at bin log position, and if GTID is enabled. And this is a very useful metric. Sometimes Debezium is slow in keeping up with the source. This is a very good metric to see if there's a delay. This one actually is useful to look at all the rows that's scanned by Debezium. So employees predated is one we're looking at. So it's scanned about 300,000 records. This is the sync dashboard we created. So yeah, so the bin log position is 197. We just pulled in 300,000 rows, and our offset is actually 300,034. And I use the Red Panda comes with a useful UI, so you can actually check the offsets and also look at the lag. So as a data engineer, like if you want to make sure that if all the data has been transferred properly, so you can try to match the offset on the Kafka side with the offsets on the sync connector. For example, yeah, so we have 121 rows and we have 122 on the Kafka side. All right. I'm just gonna do a quick, so this is highlighting the snapshot mode, which pulled in all the data that existed before the connector was started. I'm gonna quickly show how we can, the streaming component. So we're just gonna delete the connector to start one with sysbench. Okay, so that it complains because we don't have the SP tests on sysbench. So we use sysbench extensively. It's got a different set of tests. The insert does only insert loads, delete does mix of insert and delete. The update index does updates on the primary keys, and update non-index does updates on non-primary keys. So we'll just do the insert quickly. So sysbench is running. This is just going to run for 60 seconds. So you'll see that it automatically creates the table, the sync connector. The schema is inferred from the payload, and it starts inserting records. Let's just go quickly check on dbeaver. Okay, this is MySQL. Okay, we have 58,000 and 69,000. Okay, so it's going to take 20 more seconds. We can look at the dashboard. So yeah, so the bin log position is updated. We can see that it's the SP test one is, we keep getting new records. One useful tool on MySQL is is you can check the binary logs to make sure you're reading all the records from MySQL. So it's gonna take a while. So it stopped. The last bin log was 658, and the last transaction ID was 137742. So yeah, so we have the transaction ID. The reason the bin log position doesn't match is because currently we don't support transactions, but you'll see that we match this record because we don't handle transactions for now. So yeah, so I think the transfer is done. Yeah, so the rows match. That's it. Do you guys have any questions? I wasn't talking on mute, right? Okay.
No, you're not. So in summary, so Kanti, just to summarize, so what you're able to show is you can do snapshots of data from MySQL. I noticed you didn't create any schema at all on the ClickHouse side. It was all generated automatically, correct?
Correct. Yeah.
And then similarly, when you started up the SB test, the sysbench test, it created the table on the ClickHouse side and then populated it with 137,000 records.
Yes, that's correct.
Yeah.
Yes.
Yeah.
So
yeah.
Sorry, we're still working on. We do have support for alter table, where we should have. We currently support alter table add columns, but we should have alter table delete or remove columns sometime. So.
Yep. Question for you from Gilad. What is the order by in those tables? Should we go look at them?
Sure. It's ID for the SP test. Yeah.
And is that just arrived automatically from you just take the primary key from MySQL?
Yeah, so we get the primary key in the Debezium payload. And so, yeah, we create the ClickHouse table and we set the order by to the primary key.
Yep.
We also notice, so we also support composite keys where if your source database has multiple columns defined as your primary key, then this would be multiple columns.
Do you envision something where you would change the keys at some point? Because, for example, to go from something that's ordered by primary key to something that's like ordered by time, to treat it more like a time series.
Sorry, is the question if we support alter, like changes in primary keys?
Oh, no, what I meant was that, like there's different ways of, just curious if you could expand on, there's different ways of representing the data when it arrives in ClickHouse. So another thing which would make deletes work less well, but could perhaps make ClickHouse performance better would be to order it by time. Do you have any thoughts on how we might do that kind of transformation, or if that's something that's coming anytime soon?
Yeah, we didn't really target the time series data, but I thought there was another engine that we could use for time series data. So yeah, we have to plan for that.
Yeah. Good. Any other questions? So I'm just checking for those of you on YouTube, let me just check real quickly to, no, I don't see any questions on YouTube right now. So Kanti, what are the next steps on this? From your perspective, what are you working on right now?
So we're trying to get transaction support, which is currently the transactions come in a different topic. So we have to come up with an architecture of combining transactions and payload. We're working on, I think most of the data types are supported currently from MySQL. Support shards and replica and ClickHouse. We have to do some tests when Kafka rebalances, because that might change the partitions and offsets, and finish off the alter table, and eventually get to support more databases. Yeah, that's the plan.
Great. If you can just post the link on the, I think that's on your last slide. You have the link on the project. Yeah. So thank you for the talk. And just for people who are interested, we'll eventually probably, our plan is to eventually fold this stuff into Altinity.cloud, which means that it would just be automated. But our goal is to have this, this part is completely open source, and we have no plans to change that. The idea is to allow, because we think it's pretty important to, make it possible to build, not only have your data in ClickHouse, but also have the whole data pipeline be open source. So, if you got tired of, like for our own customers, if they got tired of working with us, they could just run it themselves. And vice versa. I mean, some people just, it's good enough to run it themselves. They have reasons for that, and open source is the best way to get that stuff distributed. So great, that answered Gilad's question. At this point, speaking of questions, thank you, Kanti, very much for that talk, and thanks also to Vincent. I'm going to just open it up, and if anybody has any question whatsoever on ClickHouse, we would be delighted to answer it. We have one of our support engineers, as well as a couple other engineers, and of course a bunch of very knowledgeable people on this call. So if anybody has something they're working on in ClickHouse and would like to ask questions, please go ahead and post your question. Or I've unmuted. Everybody is able to talk, so you can just unmute and go ahead and post questions. So anything about ClickHouse or anything related to it. Oh, here's a question. Actually, Kanti, I think this is kind of a question for you. Do you think to use Kafka to scale a cluster with 3 partitions to have more partitions?
Sorry, I'm confused. The question is,
yeah,
do we need to have 3 partitions in Kafka?
Yeah.
Well, let's say you have a class. You have a cluster, a ClickHouse cluster with 3 partitions, and then you decide you want to have 5 partitions. And so there is all the migrations that ClickHouse doesn't do.
So what you're saying is still like do resharding, for example.
Yes.
Because we have partitions in, because generally you would have the partitions in Kafka would it would generally match, multiplied by some constant to your Kafka shards. So that is Kanti, have you thought at all about you did mention, I believe, shards at the end. Have you thought any, about how to distribute traffic across multiple shards?
No, we've been really focusing on those MySQL partitions and how we can effectively map that into ClickHouse. Well, yeah, the problem was Debezium doesn't actually read that information, but yeah, not on the ClickHouse side.
Yeah, so just getting partition keys correctly defined is a bit of a trick, because we don't see the metadata. There was another question off YouTube, and I see one queued up for Leandro. From Leandro, if you hold 1 second, let me just pose this this YouTube question that came up. It is, somebody was asking, well, it was retracted, but it was asking if there's any plans to use Confluent schema registry. It's actually a good question. So,
yeah, we do plan to use Confluent because, yeah, it the way it's just changes in the configuration. There's no changes in the code to support Confluent. It's just a way how you define your Avro serializer and string serializer. So it should be fairly straightforward.
great. There's a question from Leandro. Leandro, do you want to just yell it out?
Oh, yes, thanks. Which do you consider are the benefits of use Altinity Sync over the Kafka engines from ClickHouse directly?
Kanti, do you want me to take that one?
Yeah, please go for it.
Yeah, the answer is pretty simple. So Kafka Engine is good for just reading raw. So for example, JSON each row. If you've got a stream of JSON coming in, Kafka Table Engine will handle it reasonably well. Even with this simple use case, though, there are some limitations. One is Kafka Table Engine doesn't currently have once and only once semantics, although there are plans in the roadmap to fix that. Another thing that it doesn't have, which is likely to be a longer term problem, is it doesn't have end-to-end dedupe. So, like if you have certain types of crashes or people, submit blocks twice, you need the ability to dedupe them from upstream. That's a problem we've actually run into. So a third thing is that the Kafka Table Engine doesn't know anything about what's happening outside of Kafka itself, or excuse me, outside of ClickHouse itself. So with the with this architecture, we have kind of an overview of like, hey, where are all the ClickHouse instances we can distribute. The connector can be a little bit smart about distributing the traffic. Again, that's something that doesn't happen magically with Kafka Table Engine. So, but those are kind of details. The big thing here is that this sync connector understands the MySQL bin log, and it knows how to represent the table in a in ClickHouse in a way that you base it. What you end up with is basically a mirror image of your MySQL data, even if it has updates and deletes. That's the big thing that the Kafka Table Engine doesn't do. Other differences, this Kafka Table Engine, or the Kafka sync connector, because it uses a connector architecture, can also support other database types. It can support many upstream databases. There's just a huge flexibility in this architecture. So that's the reason why we adopted this approach.
Great, thanks.
Yeah, and just to be clear, we did a lot of the bug fixes. We didn't do the original Kafka Table Engine. That was written by Cloudflare, but our team, engineers on our team, did a bunch of bug fixes to get it to work better. And now it's since been, there's other people in the community are working on it as well. Good.
Thanks.
Oh, you're welcome. Hey, are there questions about anything related to ClickHouse? All right. I think we may call it a day then. So one final thing. So I'd like to thank both of our presenters, Vincent and Kanti. Thank you so much for doing these talks. They're a huge amount of work, and it's great to see the technology that you took such care to show us. Speaking of talks, if you have something cool that you're doing, or even if it's not cool, but you think that it could be useful to other people, please let me know. You can post, to info@altinity.com, or you can send me a message through Meetup. We'd love to have, we're looking for additional talks in 2 months, and anything you're doing with ClickHouse, if it's even remotely related, we also invite, of course, people who don't work on ClickHouse, who do things like work on Materialize. It's kind of fun to see that. So love to have more talks. Please do submit them. We welcome everybody. So with that, I'm going to call it a day. If there are no further questions, thank you so much, everybody, and just have fun with your ClickHouse applications.
Thank you, guys.
Bye.
All right,
Thank
bye-bye.
you. Thank you, everyone.
Thank you. Bye-bye.
Thank you. Bye.